All right. Yeah, so I will be going over the flow record and flow replay features. And these are two connected features that are designed to solve a specific problem. And this was technically available previously, but it was available as a kind of a beta version of these features. And there were some extra steps that you had to go through. Many people weren't taking advantage of this because it was in that beta form. But now that it's officially released, I think this is a really powerful feature that can help you solve a lot of specific problems that you're taking a look at. All right, so what's the problem it's designed to solve? First of all, I have this really simple example. Basically, this is just flow down a plane. And what happens in this example is some of that flow is diverted into this kind of a heat sink, I'm referring to it as, but it's kind of just a simplified example of geometry. And so some of that flow is diverted into that heat sink and some of it flows around. And we're interested in where the flow goes, how much is diverted where. And you can kind of tell looking at this that none of the particles actually flow through the fins of that heat sink. All the flow is diverted around it, and in fact, if you look really closely, some of that flow it enters in here, but then actually comes back out and is diverted around. Essentially, we're just not getting the accurate flow behavior, and it's because of the particle size is too coarse for this simulation. Now, many of you have come across this in different ways where the particle size is appropriate for one scale in your problem, and maybe it's appropriate for your overall behavior, but then there's one tiny part of your model where you just need more detail. And this is the problem that this flow replay and flow record features are designed to solve. So what does it actually do? So it helps solve this problem. It helps you create a model that's you're able to refine and use smaller particles in a subset of your model. And the way that this is done is in two simulations. In the first, you'll define a flow record plane where any particles that pass through that plane will essentially be recorded. Its position, velocity, and the time of the particles passing that boundary plane will be recorded. And then you can go back and run a second simulation and kind of use that plane that was recorded previously as an inflow of sorts. It's a little bit different from an inflow in that the exact location of those particles that pass through the plane is recorded, and exactly what you had run previously in that previous simulation is now used in the new simulation, and you can be sure that you're getting the same flow behavior that you're using in your previous simulation. And we'll take a look at this example to see how that works. So the first step here, it's a pretty simple process, but it does involve two simulations. So the first step is to create a flow record, and that is found in this miscellaneous folder. So you click on the flow record and it will look like an inflow. And so you can define that inflow, that flow record plane in different ways. In this example, I used a circle. And because that fit the geometry that I was trying to record the flow through. And so I used this circle here to inserted that close to the fins of my heat sink so that I could really get in and get exactly the region I was wanted. And the closer you are to your defined problem, your problem area, the smaller particle size you can end up using. And so I defined that circle, and everything that passes through that circle in the simulation will be recorded, and it will remember all those particles that pass through that plane. Second step is very simple. You run the simulation. In this example that I'm showing, there's no special tricks in this step. You run the simulation just as you normally would with the coarse particle size. And as it's running, it's recording all that information about what's passing through that plane. And then the next step after that simulation is complete, you go ahead and click the flow replay, which is right next to the flow record in the GUI. And when you do that, everything in your simulation will stay the same except what was previously in your outline window as flow record will be replaced by a flow replay icon. And that icon will act just like an inflow. So you define your fluid that you want to use. You treat it just like you would an inflow. Then all you have to do is change the particle size and rerun that simulation. And so in my example, I changed the particle size from 1 millimeters to 0.2 millimeters. So divided it by 5. And I reran the simulation looking at just that area around the heat sink. And so that flow replay acts kind of like an inflow, except that, as I mentioned previously, it will remember where particles are passing through that plane. It won't, the particles won't come out as a circle. It will remember exactly where the particles came through that plane, and it will use that as the inflow behavior. So you can take a look at these sample results for this simulation, and you can see that now I'm getting that flow behavior through those fins, and it's looking a little bit more realistic as I expected it when I was using the coarser particles that I wasn't expecting that behavior. And you can see that now I'm ignoring everything else that's outside of that. I'm not including any of those other particles in the simulation. I'm not including the flow around anymore. I'm just looking at that area where I want to refine it. And in doing that, it allows me to use much fewer particles than I would have to if I was just going to reduce the particle size and rerun the entire simulation. So, I think that this is a very valuable tool. I think that I run across this problem all the time when I'm using ParticleWorks. There's this larger flow behavior that I'm trying to capture, but then sometimes I just want to go into the details a little bit more and capture some of this more refined flow in a specific region. And it's something that I know that you've come across. I know that it's quite valuable if you make use of this to create these submodels and actually get some of that more detailed flow behavior along with your large scale overall view of the